In this segment, we're going to be talking about geometry. Now, if you've had time to look through the Princeton Review booklet, you probably have noticed that there's about a third of the questions in the math that involve geometry. Now, it's my contention that if you learn some basic rules, which I'll be covering in a moment, you can handle any of the geometry problems that there are. As a matter of fact, I believe the geometry may even be easier for you than some of the algebra problems. And I want to build that confidence level with you. So let's get started. Okay, let's talk about angles now in relation to circles. Let me borrow a tool here so I can do a nice circle. Let's put a circle here, and I'll put a smaller circle over here. And let me borrow a line tool. I'm going to, with line segments, slice this up just like it's a pie, okay? And I don't necessarily have to go through the center of the circle here. It doesn't make any difference, because what I'm going to show you, it doesn't matter whether you go through the center or not. The only thing that matters is that every one of these lines passes through the same point in this. You'll see. Okay. Now, why have I sliced it up this way? The reason that I sliced it up this way is because I wanted to show that no matter how many times I slice it, these angles that are created, when you add them all together, they will always equal 360 degrees. And that can be, as simple as it is, that can come in real handy in some of the problems. And it doesn't matter how many times I slice this pie, it's still going, or how small the circle is, it's still going to be the same situation. Here we've just sliced it into 4 unequal slices here. And the situation is that if you add these angles together, they're still going to be 360 degrees. So that's all we really need to know about circles right now. Let's take a look now at some things about lines you need to know. What do we need to know about two intersecting lines? Well, one of the first things you need to know is that opposite angles are what they call vertical angles. This angle and this angle, these are opposite each other, are called vertical. And this angle and this angle, opposite, they are equal. This angle will equal this angle because they're opposite, and this angle will equal this angle. Now, because they're called opposite angles doesn't mean all 4 of them are equal to each other. In fact, when you add up all 4 of them, they have to equal, again, 360 degrees. Now, why do they have to equal 360 degrees? Well, it becomes pretty obvious when you just do this. Here again, you've got 4 different segments in there, and it's in a circle. And like I said before, no matter how you slice the circle, it's still going to be 360 degrees. So that's why intersecting lines always add up to, the total angles add up to 360 degrees. So if I had a circle, let's do another circle over here just to make the point, drive it home even more. If I had a ton of lines in there, let's just do the line tool, and I had lines, lots of lines, it doesn't matter how many lines, they all always have to add up to 360 degrees. So that's one thing you need to know about intersecting lines. Now there's another important thing, and it's probably one of the most important things that you need to know. And I'm going to relate this to something that you're probably very familiar with. Must have started maybe around 6 or 7 years old. So long ago for me, I have trouble remembering it. But tic-tac-toe. I'm sure everybody has played tic-tac-toe. And typically, you've got something like this, and somebody's got to go first. Now, if two people played this enough times, you know that if you go first, you go for a corner. And if you're not first, you know you better put your 0 right there, if you're using the 0. Or your O, I mean. And if two people know that, and I would say both of them are masters of tic-tac-toe, nobody can ever beat you. You know the rules. You know everything there is to know about tic-tac-toe just by learning those two rules. Now, it's my contention, I'm going to show you one other concept here, and that is what we call transversals. There are 6 rules to remember with transversals, and if you know those 6 rules, you can solve any problem that ever existed with transversals. And the rules are pretty simple, so let's get started with that. Let's do a transversal. A transversal, first let me draw some parallel lines because that's part of the definition of a transversal. We've got 2 parallel lines. And the transversal is the line that intersects them. It doesn't matter whether it's twisted that way or that way, it's still a transversal. What you learn from these 6 rules that I'm going to show you, if they give you one angle, let's say they give you this angle over here, that's not quite 40, well, maybe that's about 45 degrees. Let's say it's 45 degrees. Then you can, by knowing just that one angle, figure out every one of these other angles around here. And I'm going to show you how to do it with the 6 rules. So let's get started. First rule is called the vertical angles rule. Okay, and we talked about vertical angles a moment ago. These are the opposite angles. It says that this angle will always be equal to the opposite angle. And same here, this angle will always be equal to this angle. So we already know that one's 45 degrees. This one has to be 45 degrees too. Okay? So that's called the vertical angles are equal rule. That's your first rule. The second rule is called the corresponding angles rule. Now, what are corresponding angles? Those are angles that are in the exact same position on this top part here as they are on the bottom part. So, the corresponding angle to this one right here would be the same place down here, 45 degrees. We know that. These have to be equal. So that's called the, and the same if I knew what this one was, I would know that this one down here had to be the same as that one because they're corresponding. So that's called the corresponding angles rule. So we know 2 of the 6 now. The other rule that is always true, and it's pretty obvious here already, is that alternate interior angles are always equal. This is your interior down here, and all this stuff up here is exterior, and down here is exterior. The alternate means on alternate sides of this transversal, alternate interior angles are always equal. So I know, and it's obvious here, 45, these both are 45, and if we knew what this is, it's equal to that. Alternate interior angles are equal. So that's the alternate interior, I'll just abbreviate here, angles are equal. The fourth rule is that the Same thing happens with the exterior angles. Alternate exterior angles are also equal. Okay? Now, this angle right here is an alternate angle, exterior angle with this angle down here. So I know this has to be 45 degrees. Now there's another reason I know this has to be 45 degrees, and that's because of the vertical angle rule, okay? And so the next rule is called, sometimes it's called the adjacent angle rule, sometimes it's called the supplementary angle rule. And what it says basically is that in a straight line, there has to be a total of 180 degrees. Well, up here, for instance, we already know that we have 45 degrees here, so that means there can only be 135 degrees over here. Two added together have to equal 180 degrees. So we'll write that down. Supplementary angles, that's the angles that add up for a straight line, have to equal 180 degrees. And then the final rule, you got 5 of them so far, the final rule is that in what they call complementary, and this isn't when you tell your boyfriend or girlfriend that they have a nice haircut or something, that it's a different complementary. It's spelled with an E. That rule says that the complementary angles have to add up to 90 degrees. Now, you don't see one of those there, but if we had, let's say, something that was going through these lines, just pretend that's a straight line there, and this was 90 degrees right here, and I had another line like this, these two angles here, when they cut the 90 degrees, they have to add up to 90 degrees. So complementary angles have to add up to 90 degrees. It doesn't matter how many times I slice this, all these angles have to add up to 90 degrees. So that's your final rule. So memorize those 6 rules. Vertical angles are equal, corresponding angles are equal, alternate angles are equal, alternate interior angles are equal, and alternate exterior angles are equal. Supplementary angles equal 180 degrees, and complementary angles have to add up to 90 degrees. Let's look at one more basic angle relationship before we go look at some of the problems, and that is angles that are inside triangles. Let's start by putting a triangle up here. Let me just pick one. Let's see, that looks like a good triangle. Now, the rule that you need to remember here, and it's a simple rule, just like you knew there were 360 degrees in a circle, the angles in a triangle always have to add up to 180 degrees. And it doesn't matter what kind of shape of a triangle you have, whether, let's pick here's a isosceles triangle, where the sides are equal. You're still going to have 180 degrees here. Okay, so shape of the triangle doesn't make any difference. Whether it's a squatty little triangle or a skinny triangle or a fat triangle, they still have to add up to 180 degrees. So those are the basic rules. We've talked about intersecting lines, and we've spent a lot of time on transversals with parallel lines. We've talked about the angle relationship inside a triangle, and we've talked about the number of degrees in a circle, and when you slice up that circle, the fact that they all have to add up to 360 degrees. If you remember those basic rules, it's my contention that you'll find most of the geometry problems fairly easy.